Hello, and welcome to this video series about my build of my first ever steam engine. This is a new thing for me. I've never ventured into the world of live steam before, apart from the boiler that I built last year and still waiting for its finishing touches. This series is unfolding as I go along. As I post this, or at least as I record this, the engine isn't completely finished, although I'm well on track and it's nearly finished. But this series will include some mistakes and wrong turnings that I made along the way, and it's a very basic engine, and so the series is not aimed at people who build steam engines with greater sophistication than this. It's aimed at people who may be on about the same stage in the journey as I am, or people who are thinking about building an engine for the first time. This is the target audience for this video. This is a single acting oscillator steam engine. In other words, the cylinder moves to and fro, and the single acting bit is because the steam only pushes the piston in one direction, unlike a double acting engine where the steam comes in at the bottom of the piston and above it. There's numerous designs for these engines on the internet, and people design their own, but because of the mechanical layout of the thing, I needed to have a template to work from. So what I did was I looked around and I chose this one here, which is by Steve's Workshop. The URL is in the description below. Now, I like Steve Workshops because it's a nice little machining project. The components are all made well, but also it's clearly explained and simply laid out with nice plans that are easy enough to read, and it's metric, and given that most of my tooling's metric, I thought that would be a good place to start. This video series itself, the installments are based on each part, so each installment will follow a part as it develops, a part of the engine, so that it's not necessarily in strict chronological order, so there may be a little bit of overlap between episodes. Now, the majority of oscillators are fairly square in design, and Steve's version is no exception. I mean, when I say square, I mean the forms in it are rectilinear. I think that's fine. It's nice and simple and unpretentious, but I decided to get a little bit more creative. Having made quite a few paintings of this sort, I thought I'd include a bit of that kind of feel into the design of the steam engine. So here is the marking out of the aluminium plate, about 12mm thick aluminium plate, to make the frame, or standard as it's sometimes known. You can see it's rather unconventional marking out, very sketchy and scrappy looking, and you may be raising your eyebrows at this already, but it's based on the way that I used to paint. I made sure that the whole form was big enough to accommodate the dimensions of Steve's original design, but then I worked around that in a sketchy way to create a shape that could then be refined as I cut it down to something that looked reasonable. So I marked it out like this, and then I made the shape by a process of chain drilling, of sawing, and then the use of drum and belt sanders to refine it down to its current form. So at this point, I didn't make any videos of the cutting out or sanding of this, but the video now follows on with my starting to machine the frame with holes to mount it on its base. So here's my setup for milling the bottom edge of the frame so that it's flat and straight, and it holds the whole frame in the right kind of degree of verticality to make it look right, due to its organic shape. And while I've got this setup going, I may as well drill and tap 2 holes in the bottom edge of the frame as well for the mounting screws to attach it to the base. So basically I've got a 90-degree angle plate here and 2 toolmaker's clamps, and I'm just checking the the lines in the right orientation with my height gauge here on the mill table. So we're really set up and ready to go. Well, a little bit of progress already. The shape of the frame seems to be fine. I'll have a final check of that, and may need a little bit of balancing up a bit, but I'm feeling it's okay. The bottom of the frame has been milled nice and flat, and there are two drilled tapped M5 holes in the base of the frame to fix onto the base of the engine when it's made. So there's the frame. Still to be drilled for it, the pivot and the bushing for the main axle. But there's the basic shape of it. I'm happy with it. I think it's okay. It's not rough looking. It's a pleasing shape. So there we go. Drilled and tapped. On to the next phase. Now marked out. You can see in quite a sketchy way, but it'll work because it'll be sanded and shaped. I've marked out a kind of curved sided triangular base for the engine. There's a fair bit of work in getting this tidied up, but needs must. You can see how the engine will sit in there like that. I think it'll look a little bit funky. So come back to you on that later. So here's what I came up with. It's quite a pleasing shape, I think. Each side's a different size. It's quite an irregular but nevertheless quite smooth shape. It came together quite quickly. I used this belt sanding attachment on my Coronet Major wood turning lathe, and it's got one kick-ass motor on it, and everything in the shop vibrates and things fall off shelves and so on, but it's worth it because you really move metal fast with it. And then to finish it off, well, it's not finished yet, but to take it to the next stage I just used a flat wheel on my drill press, and it was all much quicker than doing the inside curves in the frame of the engine yesterday, because well, outside curves just happen quicker than inside curves do. And I was using different types of abrasives as well. So I'm quite pleased with this. So what remains now is, well, a lot remains now, but for the frame, for the base here, I'm going to use transfer punches to, transfer screws to mark the screw holes on the base here, and then I'll drill it and countersink it underneath and secure it with two M5 tap head screws. Coming together quite nicely. This is the first time I've used transfer screws. For those of you who aren't aware of them, it's a very clever but very simple idea, which is that, I don't know if it's going to be very easy to focus here, but basically you've got a little, whatever size your threaded hole is, this is M5, the bottom of that is M5, and the top of it is a little sharp point, and here is a little kind of key thing that you screw them in and out with. So basically you can leave two little sharp points sticking out of the holes, and then you just sit it on top of your marked out area there, and you give it a little tap, and then you've hopefully left with two little holes which show you where to drill. So I'm going to have a go. Well, seemed to work well. You can see the two little holes there, which I'll pick up with a punch and enlarge a little bit, and then centre drill clearance holes for the screws, and counterbore it underneath so that the screw heads are flush with the base, underside of the base. Okay, this is the underside of the base, and you can see my old scratchy marking outlines there. I decided to turn it over. But underneath the bottom of that end mill is a hole. I've used a wiggler to find the centre of that hole, and I'm going to use the end mill to counterbore. The counterbore will be 6mm deep because the head of the cap head screw is 5, so it'll be 1mm below the base, the surface of the base. As John of Double Boost points out, this is one of the very rare occasions where it's permissible to use an end mill in a drill chuck. Ooh, spooky. So here's the frame now attached to its new base. I'm quite pleased with this so far. It's not an engine yet, it's a stamp or something like that. I don't know, but it looks quite good. I'm particularly pleased with the shape of the base. You can see there the cap head screws and their counterbores, and everything's tickety-boo. On to the next phase soon.